is Deadliest Stun here, and today we're going to do a BCD clock on a 5x8 dot matrix display. So the display, it's 8 columns by 5 rows, and it's a one color display. It's a red display, so it got red LEDs, and the idea is basically to take a row, one of the 5 rows, and put a number of it corresponding to year, month, day, hour, minute. Though this approach, there is a problem, because the implementation that I did, I just used until the 5 column, so it's a 5 by 5 in the end. With 5 bits, I cannot express a number like 16. I need a rather more bit. So what I did is it's a hack. So the hack is simply, I'll take 4 bits, show the 4 first bits, and then after I'll show the last 4 bits of the number. So it will show all numbers in 5 bits on the rows, and if a number has another 4 bits to show, after 300 milliseconds it will going to show the other 5 bits, and it will be switching on between those. And of course the numbers will increment seconds to minutes, minutes to hours, and so on. So it is basically it. I admit that it's a little bit hard to read if you don't know BCD by heart, but it's an interesting product nevertheless. So as brains, I use an ESP8266 with a LOL board, and to switch on and off the LED pins I used a 174-138 and a 74-374, which is a bunch of D flip-flops, DQ. So the 74-138 is it could be understood as a converter. It converts 3 bits to 8 bits or a byte, and it uses a BCD code like 0000001, 010, and so on until 111, and it outputs on its 8 output pins the value corresponding to it. So here is an example. If I have 3 zeros on it, it outputs a 0 on the first output, and the rest will go to high. Or in other words, the first output is going to be low and the others high. And to it works, the 4th and 5th pin, they both must be set to low, and the 6th pin should be set to high. And if I do if I go and set A to high and BC to low, the second output will be low, and the other outputs will be high. So it could be seen as this table. It has the BCD code on the left side, and on the right side there is the output, and you can see as the diagonal of it is our output. And the 74-374, it works in a very simple way. To it functions, you have to set the first pin to low, and it has a clock pin. So what a clock pin means? A clock pin means that the chip will only do its job when you set the pin clock to high and back to low. Of course it functions on the high, on the rising edge of the input. You could set to high and let it be on a high, and the next time you could low high, but I prefer to set it low. Just it's more simple this way. So the way it works, the D are the inputs of each flip-flop, and the Q is the output. So there is DQ1, DQ2, and so on and so forth. So to set 1 to the first output, the first Q, you set 1 to Q, to D, and the clock, I put this blue here, mean that's in this very moment it's low, and now when I set the clock to high, the Q will go to high, and the D doesn't matter right now since I don't have a clock input. So D, you could just set it there at 1, it could be at 0. I like to be let it be on 0, just it's more simple this way. The same thing with clock. So you could use this to set or unset a value. To unset a value is the same procedure. You let D be 0, and you set clock to high, and this is going to be 0. And you set clock on low again, or let it be on high, doesn't matter. So this is the matrix, this is its diagram. It got 14 pins. I label it this way, it's more simple. 1 to 7, 8 to 14. And it got 8 columns and 5 rows. I begin to the numbering at 0, so it's like more like a coordinate system. At the top left most LED as the 0 of the coordinate system, and its pins is labeled as this way. So what does this mean? This means that if I want to set this row high, I need to set the columns pins high and the row pin that I wanted low, and the others must be high, of course. So in this way, if I want to set this particular LED on only, I need to set this high and this low, and it will be on. In this case, if I want to set this and this, and to set the pin 2 and the pin 7 high, and the 13 pin low, and you must do the same procedure to the other columns. And in this example, if I want to set these two gentlemen high, I need to set pin 5 high and pin 4 low, and afterwards I need to set pin 8 high and pin 4 low. So this in here, it's a rather more complicated thing. This is actually the clock. So to the clock works, we need to use multiplexing. Multiplexing will simply switch any of the LEDs on and off if we want them to be or not. So in this row, for example, I only need this LED on. So I set 2 high, 13 low, and the others I don't need them. So I let 7, 1, 5, and 12 low, and 13 it doesn't matter since there's not a circuit of current flow, I mean. So on this second row, it's the same procedure. This I'll set low, the 2, the pin 7 and 1 high, and this gentleman low, and this 2 low. And there you go. It's pretty straightforward. And this is a simulation of the clock. So the clock will show this. This is year. Of course, I cannot do the 2000 thing, so I just do the last 2 digits, the month, the day, the hour, and the minutes. Of course, there is no track of seconds, but the screen most of the time flashes at 300 milliseconds, so you could use that just to see that the time is flowing. Here's an example of how it works. I have the 5 bits of it, so it's 0, 0, 0, 0, 1, and the last 5 bits, which is 0, 0, 0, 0, 0, 1, 0. So the actual number is 1, 1, 0, 0, 0, 1, which when you go to calculator, binary 1, 0, 0, 0, 1, DAC, we get 17. So in case you're wondering about the others, you can go in the Krypton 1, 0, 0, 0, 0, and we get 16. So it's 2016 and 0, 1, 1, 0, 0. The month is 12 December, 0, 1, 0, 0, 1. Today is 21. Of course, this is just for testing. I didn't put the actual date. And here you can begin at 1, 1, 0, 0, since the leftmost zeros doesn't matter. If there is no 1, it's 4. The hour was 4. And on the end we got this one here. And this is a live demonstration of the screen, and as you can see, I taped the three right columns that are not used just for reference, and the LEDs are not that bright. It's mostly of the blame is mostly on my power supply. It's not a great one. It doesn't outputs a good current. I mean, it's not that at the first glance you're going to get it, but it is, you know, it's in binary. But you can kind of get it. It's a very cool product though. So this is it. The code and the diagrams, the schematics, will be on the description of this video. And if you like it, you could subscribe and click the like button and share with your friends. And any ideas, any suggestions, you can comment down, or anything that I made wrong, you can comment down on the description of this video. And I'll see you later, guys. This is Dead Stone.